what we're talking about today is types of deductive reasoning. Remember the very first section we talked about inductive reasoning. Inductive reasoning, we use examples to make some conjecture or some false or some true statement, right? So things like you saw a pattern, you saw this pattern, you said, okay, this is my conjecture on the pattern, this will be the next number. That was using inductive reasoning. Okay. Now we're going to talk about deductive reasoning. What deductive reasoning is it uses either facts, rules, definitions, or properties to reach some logical conclusion, some conclusion that's true. This is 2-4. Okay. So deductive reasoning uses some types of examples, rules, definitions to come to some conclusion. There's two laws we talk about when we talk about deductive reasoning. Both of these laws, okay, are on your postulate sheet that I gave you that you can use on the test, called the Law of Detachment and the Law of Syllogism. Okay, these are both on your sheet that you can use on the test, on your postulate sheet. Okay. Deductive reasoning uses facts, rules, definitions, or properties to reach some conclusion. Okay. First, we have the Law of Detachment. What the Law of Detachment, again, this is on your postulate sheet that you can use. What the Law of Detachment says is if statement P, then statement Q is true, and P itself is true, then Q is true. Remember, this arrow is our conditional if-then. So if statement P is true, if P then Q is true, and statement P is true, therefore statement Q is true. This is called the Law of Detachment. The Law of Detachment has two statements, P and Q. Okay. So let's look at an example of that. So for example, the Law of Detachment, this is on your postulate sheet. Okay. If you multiply two odd numbers, then the product is an odd number. 17 and 29 are odd numbers. So what conclusion can I make based on if P then Q up here? Then their product is an odd number, right? Okay. Again, this is an example of the Law of Detachment. So I had if P, so there was P, then Q was true, right? If you multiply two odd numbers, then the product is an odd number. And then P is true, 17 and 29 are odd numbers, then Q is true. 17, the product of 17 and 29 is odd. Okay. That's called the Law of Detachment. If P then Q, P is true, therefore Q is true. Okay. Questions on this one? Does it what? Good, okay. Let's look through a couple more here. If you pass the test, then you got at least a D. Bob passed the test, so what conclusion can I make based on the Law of Detachment? You're right, that Bob got at least a D. If P, then Q. P is true, he passed the test, therefore Q is true, he got at least a D. Okay. Law of Detachment deals with two statements. Here we have 1, 2. Okay. P is true, therefore Q is true. Okay. Kind of see how Law of Detachment works here? We got one more here. Okay. Nope. Law of Syllogism. Okay. So detachment uses two statements. Law of Syllogism uses three statements. It says if P then Q is true, and Q then R is true, then P then R is true. Okay. We're going to look at a different example than this one first. But I have three statements, P, Q, and R. And it starts if P then Q is true, and Q and R, therefore P and R. It's almost like the transitive property. Remember the transitive property says like if A and B are equal to each other, and B and C are equal to each other, then A and C are equal to each other. Okay. This is similar. But we're talking about statements and conditional statements. So I have three different statements to use for the Law of Syllogism. Okay. So for example, if it is raining, then there are clouds in the sky. If there are clouds in the sky, then it is dark outside. Okay? So if I have statement P, statement Q, statement R, the Law of Syllogism says if P then Q, and Q then R, then P then R. So what would be my logical statement based on or my conclusion based on the law of syllogism here. Yeah.
So if it is raining, then it's dark outside.
Right. If it is raining, then it is dark outside. Okay. Again, that was statement P and statement R. If it is raining, then it is dark out, or then there are clouds in the sky. If there are clouds in the sky, then it's dark outside. Therefore, if it is raining, then it is dark outside. This is an example of the law of syllogism. Okay, I have three different statements here, right? Detachment only had two. Okay, three different statements here for law of syllogism. This would be my logical conclusion based on the law of syllogism. Questions on that one? No? Okay, let's look at another one. If you do all your homework, you will get an A on the test. If you get an A on the test, you will pass the class. So what conclusion can I make based on the law of syllogism here? If you do your homework, you will get an A. If you get an A, you will pass the class. Therefore, what? Therefore, if you do your homework, you will pass the class, right? If P, then Q. If Q, then R. Therefore, if P, then R. If you do the homework, you get an A. If you get an A, you'll pass the class. Therefore, if you do your homework, you will pass the class. P, then Q. Q, then R. Therefore, P, then R. Okay. So here I want you to use the law of syllogism to determine whether a valid conclusion can be reached from this set of statements. If Sue attends the dance, she will go with Mark. If Sue goes with Mark, Donna go with Albert. Therefore, what statement can I make based on the law of syllogism? Now, this always doesn't work. Sometimes, and I'll show us an example of that in a second, there's no valid conclusion to be made here. But can I use the law of syllogism here to make some valid conclusion or valid statement here? Yeah, why?
If Sue attends the dance,
Yep.
Donna will go with Albert.
Exactly. If Sue attends, Donna will go with Albert. So that is logic. You can logically conclude that based on the law of syllogism. If Sue attends, then she will go with Mark. If she goes with Mark, Donna will go with Albert. Therefore, if Sue attends, Donna will go with Albert. Yes, question.
So it's kind of like the DirecTV commercials.
Yes, how so? Right, yes, say that. I'm glad you brought that up. Like, do you remember what it says? I don't remember what it says, but you're right, yes.
If you have crappy internet or something,
Uh-huh.
you look out the window. If you look out the window, you'll see a murderer.
Yes, yeah.
And if you see a murderer,
Yeah, it is exactly like those commercials, right? They give you a bunch of conditional statements, and then conclusions follow from that. Yeah, that's a good point. Glad you mentioned that, right? And you see those a lot oftentimes on TV, right? That if you do this, then this will happen. If you do this, then this will happen. Okay? This law of syllogism gets us to arrive at some conclusion based on these statements. Yeah, good point. How about this? If Mel and his date eat at the steakhouse, they will miss this before going to prom. They will miss the senior march. The steakhouse stays open till 10. Can you make a valid conclusion based on the law of syllogism from this statement? No. There's no valid conclusion here, right? It doesn't matter that it's open till 10. I can't make a statement from this. If P, then Q, and then I just got some random other statement. See? It didn't flow together here that I said if P, then Q, and Q, then R, therefore P, then R. Okay. So that one is no valid conclusion. Again, both of these themselves might be true statements, okay, but I can't arrive at some conclusion using the law of syllogism. How about this? I am nobody, nobody is perfect, therefore, right? That's syllogism. How about this? Stealing refrigerators is hard work. Hard work is good for you, therefore stealing refrigerators are good for you. Okay. Right, syllogism doesn't necessarily work for every case, but these would be examples. If you steal a refrigerator, then it's hard work. If it's hard work, it's good for you. Therefore, if you steal a refrigerator, then it's good for you. Okay. Right. How about this? If you have a tuna sandwich, it's better than nothing. If you have nothing, it's better than unlimited wealth, health, and happiness. Therefore, if you have a tuna sandwich, it's better than unlimited wealth, health, and happiness. Law of Syllogism said so, so it's true. Right? Okay. Okay. All right, so they're all over the internet. They're called syllogisms. Get it? Because it's using law of syllogism, but they're silly. Yeah, they're syllogisms. Everybody get it? Yeah. Okay. All right, good. So if anybody can, I'm not going to make you do this, but if anybody can think of a good one, I was going to have us try and come up with good ones, but if you can think of a good one, like the stealing refrigerators one is my favorite. If you steal a refrigerator, it's hard work. Hard work's good for you, so on. Okay? What we are going to do is a little deductive reasoning puzzle and exercise here. Okay? So good job with the activity. Let's look at this one. I want to know, is this because law of syllogism, detachment, or is it invalid? It doesn't work. Okay. So let's look. If a children's movie is playing, Janine will take her little sister. If Janine takes her little sister, she will buy popcorn. If a children's movie is playing, wait, that should say Janine. Sorry, because there was a typo in this. This is Janine. Janine will buy popcorn. Is this syllogism, detachment, or neither? Yeah. This is law of syllogism, right? Okay. Because I have if P, then Q. If Q, then R. And if P, then R. Okay, that is law of syllogism. Good. How about this one? If a polygon is a triangle, the sum of the angles on the interior are 180. GHI is a triangle, so the sum of the interior angles of a polygon, GHI, is 180. So I have if P, then Q. GHI is true by P. So, yep. GHI is true by Q. It is a law of detachment.
What's detachment?
Detachment has two statements. It says if P, then Q. And if P is true, then Q is true.
Well, is polygon in that? Oh, true.
Okay.
Is polygon in that?
The polygon of if a polygon is a triangle.
The second one. You don't have a polygon.
Right, yeah, I just missed that. So polygon GHI. So if P, then Q. P is true. That's a triangle. Therefore, Q is true. The interior angles add to 180. That is an example of law of detachment. Detachment, two statements. Syllogism, there's three. All right, how about this one? If your alarm clock goes off in the morning, then you will get out of bed. If you ride a bus to work, then you go to work. Detachment, syllogism, valid or not valid? This one is not valid, right? I said if P, then Q. And then I have if R, then S. I have a totally different statement, right? I can't conclude anything from that. It's not valid. Okay, how about this one? Detachment, syllogism, and either. If the sum of the squares of two sides of a triangle is equal to the square of the third side, so it's a Pythagorean theorem, then the triangle is a right triangle. For xyz, xy squared plus yz squared is equal to zx squared. So the sum of the squares of the sides of the triangle equals the square of the third side. Therefore, xyz is the right triangle. Detachment, syllogism, neither. Right. This one is detachment. I have P, the sum of the squares of the triangle is equal to the third side, Q. Then it's a right triangle. P was true, then Q was true, So this is the law of detachment. I think I got one more. If Link wants to participate in wrestling, he will have to meet an extra 3 times a week to practice. Okay. If he adds anything weekly to his schedule, he cannot take karate. Therefore, if he wants to participate in wrestling, he cannot take karate. Detachment, syllogism, invalid.
Syllogism.
Here are a few syllogisms. Any other guesses? This one's syllogism, right? Statement P, he wants to participate in wrestling. Q, he has to meet extra. If he meets extra, he can't take karate lessons. This one's law of syllogism. If P then Q, and Q then R, therefore P then R. Okay. And that's it for deductive reasoning.